We have a set of data, and we want to find some predictions on that data. And so how we do that is by using data sets collected through either data mining, through Facebook, GitHub, Twitter, whatever you can find useful. And we apply algorithms and try to find some insights on that data. So let's start with an example. So Netflix, back in 2006, had a contest where they wanted to get 10% better movie predictions, or recommendations, I should say, for their users, and they offered $1 million prize. And it's that we could think of each person as having a profile. So you could think of it as Facebook profile, Twitter profile, and Netflix profile. And each profile has a given set of features for each individual person. So we have, let's list some interesting features. We could think of, does the person like action, comedy? Do they like the leading actor? Is that a primary factor in influencing whether they would recommend the movie or not? I guess plot setting, you could think of it as foreign films, or French, or I guess German films maybe, or American. So basically what I'm trying to say is that each thing listed here can be features for a given formula that gives a prediction when you feed the input data into the given function generated from these listed factors. And there could be, a lot of different factors. It really does depend on how accurate you want to be, but then that leads into what is called overfitting, which is a problem in machine learning. How a function is generated is that given, we could list that the total data set for each applicant, so let's just list each Netflix applicant as X subscript I, and its reciprocating output as Y subscript I. So we could think of, if we have, this is a really small data set, but if we have 5 profiles, each with the same features but different weights on those features, is that we have applicant 1, so X sub 1, comma Y sub 1. So this is the applicant's profile / feature vectors, which is just a vector within this context could be symbolized as just like a list of the factors listed here, and extra ones that you might find useful. And so we have X1, Y1. Y1 is the output. So it's like the recommendation that it's whether the applicant within this context would be satisfied with the recommendation that Netflix provided, given the profile applicant's features and reciprocating weights. And applicant 2, you get the idea. And so how we find a correct output, or one that is reliable enough to give an accurate prediction, is through first picking what's called a hypothesis set. And a hypothesis set is just a space of the type of formulas that you would believe that could be what's called the target function. And what the target function is that it's the function or the formula that is actually in nature. So with Netflix, the target function is like the actual function that correctly, like 100% predicts whether that applicant would be satisfied with the movie recommendation provided by Netflix. But the funny thing about the target function is that the target function could actually never be found. It's sort of, you could think of that like in calculus, how we have a limit, and with this limit, I mean, it gets super close to the x-axis, but no matter how far down the line or down the curve, it will never actually converge into the x-axis. And so we could think of it like that. It's sort of like no matter how predictable our formula is, we can never be 100%. And then that's just an issue of, statistics and probability. Whenever you bring something into real life applications, it's never, its output is never like a function reliability output. Like it's always subject to probability. And so how we actually generate that formula after we gathered all the data, and keep in mind that the data that we are getting is historical data. We basically choose, like how I said previously, a hypothesis set, which would just be options of the functions or polynomials that we would think would best predict or give the best prediction given our inputs and our desired outputs. And the desired outputs, going back to historical data, is that we can compare the output the output from the algorithm with the historical data, or historical data is sometimes slang for like, you'll sometimes hear training data. And so we could compare the historical data with the outputs given by the algorithm and see if they match up. So once we find out all these hypotheses, the hypothesis set, then we can choose our algorithm. And what the algorithm does is that it really just walks through the hypothesis set and tests each hypothesis within that given set. So we could think of it as capital H as the hypothesis set. And within this set is like one hypothesis element in a series, maybe. So what I mean by that is that capital H hypothesis set has an element of, small h of 1, comma, small h of 2, ... to small h of n. And so this algorithm will actually walk through each hypothesis. And what we want is a hypothesis that provides the best relationship between that given hypothesis and the target function, which we could actually never know. It's pretty interesting. So I guess we could summarize it. So we're given data with an x that represents an input and a y that represents an output. And then we feed this data into an algorithm that uses a hypothesis set to define the scope of what functions would probably be best that matches the target function the most. And why we would even include the hypothesis set is because I guess time could be a factor in choosing a hypothesis set. You could have no bounds, you have no restrictions with hypothesis set, meaning that it could be really any function, but if you are on a time restriction, you could choose hypotheses of linear time. So that would be a perceptron, for example. Once the algorithm chooses the best hypothesis within that given hypothesis set, then that's pretty much our function or polynomial or formula that we want, that we desired. We could represent that hypothesis function as g of x that approximates f of x, which could be the target function. So the hypothesis function approximates the target function. Oh yeah, and like with weights are pretty much, if the algorithm misclassifies an applicant profile, what the algorithm will do in terms of the perceptron is that it will change the weights, the weight vector of the given hypothesis function that's testing. And so we could think of that as, for example, just arbitrary h of x is equal to weight 1 and then x plus weight 2 y plus weight 3 z. And each variable represents a different factor. So this could be, action for Netflix, if the given applicant likes action. Y could be comedy, and Z could be, does the applicant like foreign films? And if the algorithm misclassifies the point or the output given by the historical data that we're testing from the training data, then it will change the weights. Because if you think about it, you could only augment or try and better the formula or function by only changing the weights, because the inputs are always constant. The hypothesis, so the h, is the one we're just testing, and the h of x is just the output. So really, the thing that we can only change within this given context is the weights. And the weights could be, you could think of weights as the importance of the factor. So we could say that, that action for movie recommendations is really more important than, let's just say, comedy in terms of recommendations. So, it could be, like, I guess, like any scalar number, a real number, fraction, anything. The weights can even be negative, signaling that, for example, for a negative weight, if a person has credit debt, well then, in terms of banks giving credit approval, they would give the factor of credit debt a negative weight because that's a bad property to have. And going back to banks and credit scoring, for you to get a better idea of what factors can be, because this seems to be really limited, there's lots of interesting examples in terms of credit scoring. So I have, this is a document, Data Enhancement Services by Experian. So we could take a look at some of these features. They're pretty cool. Gender code. We have marital status, person type, education. Yeah, so there's a bunch of interesting factors that they use for their predictive modeling. There's also this other document if you want to learn more about how to actually credit score yourself. You could do that through programming. In terms of their hypothesis set, you'll see right here that they choose theirs as the random forest.